Welcome back, guys. It's me, Mr. Frederick, once again, and excited to be here like every video we do. And today, we're going to be talking about isotopes, all right? And some of y'all may be wondering, what is that, Mr. Frederick? I don't get it. I said, that's a good question. And today, we're going to answer that question. What are isotopes? So, let's get it. Let's go. Isotopes, basically, are just certain atoms, not all, certain, that have the same number of protons, all right, but they have different atomic mass numbers. Key difference, all right? So they can have the same number of protons, but different atomic mass numbers. So I'm going to show you some examples here in the next slide right here. Here you have, you see, let me move this a bit so it can be more clear to see. There it is. Very good. So here I have 3 examples of isotopes of carbon. All right. So here, normally carbon, stable, you have carbon, you have here carbon 12. Okay. So carbon 12, it has 6 protons and 6 neutrons. Okay. So when you have the mass number, 6 plus 6 is 12. All right, so let me write that down here. 6 plus 6 equals 12. All right. So here, this also is carbon, but it's called carbon 13. Why? Because it has 6 protons. Just make that different color. It has 6 protons, but it has 7 neutrons. So its mass number turns out to be 13. Okay. And we have carbon 14, okay? So it has 6 protons, but 8 neutrons. So its mass number is 14. But they all are carbon. See, the only difference is that they have different mass numbers, okay? The mass number of each is different, but they have the same atomic number. They all are carbon. It's just that one is called carbon 12, another is carbon 13, another one's carbon 14. Okay, so some that you could see here, those are some things that you will be seeing. Isotopes are like that. So if they have the same atomic mass number and the same atomic number, then it wouldn't be an isotope. So say it was 6 protons, right? And the mass number is 12, and then you have another one that's the same as the first one, then it wouldn't be an isotope. It would be an exact type. So, example, if I wrote that the mass number is 12, and 6 is the atomic number, and then I write it again. 6 again and 12, they're going to be identical. It'll be the same. Okay? It wouldn't be an isotope. So to make this really clear, the isotopes have to have different mass numbers, but the same atomic number. So to have those different mass numbers, the key difference is the difference in neutrons. So you see here, so I'm going to mark that in red, circle that in red. The neutrons in the first one for 12 is 6, but for carbon 13 it has 7 neutrons, but for carbon 14 it had 8 neutrons. Okay, thus that changes each carbon to be different, making a different isotope. All right, so those are the things that you just need to keep in mind. So isotopes have the same different mass numbers, but the same atomic number. Okay, so they're all carbon. The only difference is that their mass numbers are different because each of them have different number of neutrons. If they have the same amount of neutrons and carbons as the one to this left or right, it wouldn't be isotopes. It would be an identical same atom. Okay. Just to keep that in mind. Alright guys, take care. Be safe. And this is Mr. Frederick out. Ciao.